Euler's number, or E, is a value that a lot of us have come across, especially those who have studied engineering, economics, statistics, and other sciences. It is an irrational constant, just like pi, which is approximately equal to 2.718. Now the question comes here. Why is E equal to 2.718? And that is the entire point of my video series, to derive Euler's number. The first video, which is the video you're watching right now, is going to be about the prerequisites of understanding the entire derivation. I'm going to talk about logarithms, exponentials, a few of both of their properties, and I'm going to have a very small discussion on the fundamental theorem of calculus, which I'll talk about in more detail in my next video. Okay, so let's start off. I'm going to start off first with exponentials. Second. Okay. Now, what are exponentials? You must have heard of this word called exponents, powers, exponentials. Let me tell you the difference amongst all of these. Now, when I write the expression a raised to x, that is an exponential, because an exponential is the entire expression of having a value which has a power. Now, in an exponential expression, this value at the bottom, a, is called the base, and the value at the top is called the power, or the exponent. So the entire expression a raised to x is an exponential, a is the base, and x is the exponent or the power. Now let's understand what this actually means. So for example, let's say we take this value called 2 raised to the power of 3. What does this mean? It means that the base, or 2, has to be multiplied to itself exponent number of times. This means in this case 2 is multiplied to itself 3 times, which is equal to 8. Okay, now let's have a look at a few properties regarding exponentials. So you'll notice property number 1. It says that if a raised to a certain power is multiplied by a raised to another power y, the answer is a raised to x plus y. So you're adding the exponents up. Now, why is this so? Let's look at a small example. Let's think of 2 raised to the power of 3 times 2 raised to the power of 2. So if you think of it, this is essentially equal to 2 times itself 3 times times 2 times itself twice. And if you notice this whole expression, you'll see that 2 is being multiplied to itself 5 times, right? Which is just equal to these two exponents added together. Now the important thing to note here is that the bases should always be the same. So you'll see even here in the expression for property number 1, the two bases are exactly the same. Let's try to understand the reason for that. So let's say I took 2 raised to 3 times 3 raised to 2. That's equal to 2 times 2 times 2 times 3 times 3. Can it all be represented as one single value with a power? Just one single base with a power? No, that's not possible in this sort of a case. That's why having the bases equal to each other is a very important thing when trying to use this property. Okay, now let's have a look at the second property. This second property says that if a base raised to a certain power is now raised to another power, so a raised to x is your first exponential, and then that entire value is raised to another power c. In that sort of a case, the two powers are just multiplied by each other. let's have a look at an example for this to understand why it is so. So let's take something like this. 2 raised to the power of 3 the whole squared, or raised to the power of 2. Now let's first try and tackle 2. Okay. This means that 2 raised to 3 is being multiplied to itself twice. Now have a look at a single expression over here. One of these expressions is 2 times 2 times 2. So if you see, 2 is being multiplied to itself 3 times twice. Therefore, you could say it's being multiplied to itself 3 times twice, which gives you the exponent of 6, and hence 2 raised to 6. Okay, now let's move on to the next topic, and that is going to be logarithms. Now, logarithms is an interesting concept. It's something called the inverse function of exponentials. I'll discuss inverse functions in the next video, but for now let's just understand what they actually are. So here too, let me just write down the basic expression first. You have a log, you again have a base, and you have a value. So this expression would be read as log of A with the base of B. Let's look at an example. For example, log of 8 to the base of 2. Now to understand what this is equal to, ask yourself this. 2 raised to the power of what will give me 8? And given what we just discussed, 2 to the power of 3 would give you 8. And hence, log of 8 to the base 2 is equal to 3. Okay, now let's have a look at the properties. The first one says log of b to the base b gives you 1. Why is that? Now ask yourself this. B, which is the base, to the power of what is going to give me b itself? This means b multiplied to itself how many times is going to give you b? Once, right? It doesn't have to be multiplied to anything. So b raised to the power of 1 would give you b. And hence log of b to the base of b is equal to 1. For example, let's take the number 2. So log of 2 to the base 2 would be equal to 1. Okay. Now let's have a look at the second property. Now the second property is an interesting one and has a very interesting derivation to it. Okay. So it says that the log of a times c to the base b is equal to log of a with the same base plus log of c with the same base. Now let's think of this. Based on what we understand about logarithms, we could say that b raised to some exponent x is giving me a, right? And b raised to some exponent y is giving me c. Okay. Now, let's try and multiply a and c. Okay. So we're multiplying a with c. So a times c means it is equal to b raised to x times b raised to y. Given our assumptions. Now let's have a look at the next step. If you multiply two exponentials that have the same base, based on property 1 that we just discussed for exponentials, we could say that this is equal to b raised to x plus y, right? Now, we have a times c is equal to b raised to x plus y. Now what do? Let's log both the sides. Let me tell you why. Because if you log a times c, what you're going to get is log of a times c to the base b. And we're trying to get this left-hand side of the property to be able to prove that it is equal to this right-hand side. Okay? So now let's say we change this to log of b, a times c. And this is equal to log of b b raised to x plus y. Now what do? We have found the left hand side, but we still haven't understood the right hand side. So let's have a look at that. Log of b raised to x plus y with the base b. What does this mean? Now think of something I talked about earlier on how you can solve a log. Ask yourself, the base raised to what power is going to give me this value? So b raised to what is going to give me b raised to x plus y? If you see, this expression is actually very simple. It is equal to x plus y, right? So now we have x plus y on the right hand side. But now what do we do with x plus y? Has it still given us the right hand side of the property? Actually, it has. So let's go back to looking at b raised to x is equal to a and b raised to y is equal to c. So the fact that b raised to x is equal to a, doesn't it also mean that the log of a with the base b is equal to x? Right? And the log of c with the base b is equal to y. So this means that the right hand side has become log of a plus log of c, both to the base of b. Therefore, property 2 has been proved. I hope that makes sense. Okay, now let's move to property c. That says that log of a raised to the power of c with the base b will give you c times log of a to the base b. So let's try to expand this. Let's take an example here, okay? Let's say log of 2 to the power of 4 raised to the power of 3. What is it equal to? So let's simplify this. This would be equal to log of 4 times 4 to the base 2. Now based on property 2, what we saw was that when values are multiplied, you can just add their separate logs. So this would be equal to log of 4 with the base 2 plus log of 4 to the base 2 plus log of 4 again to the base 2, which is just equal to 3 times log of 4 to the base 2, which proves our property again. Okay. Now let us move on to the last topic for today. We're going to have a very brief discussion on the fundamental theorem of calculus. Just as an introduction to it, I am not going to talk a lot about it. I will talk about it in more detail in my next video because it requires some extra understanding. Okay, but just to explain it, this theorem talks about differentiation or derivatives. What are derivatives? In very simple language, it is the change in a certain function with respect to a certain variable. Now, all of this sounds very technical, but it will be clearer once we discuss it in detail in the next video. But to just show you this formula, just explain this to you very briefly. If you see, the function is basically saying that I am looking at a certain value at x plus h and x. So for example, let's say if we were talking of speed versus distance. This is speed, this is distance. Distance is x. So let's say x denotes distance and f of x, or the function of x, a function of distance, is speed. And let's say this is how the graph looks. So basically what we are saying is that at this point x1, have a look at this value of f of x1. And now a very small amount later, so at x1 plus h, h is limiting to 0, which means that it is very, very, very small. So you're looking at a distance that's at a very small distance from x1. And you look at the function's value over there. So x1 plus h. Now you find the difference in these two values and you divide it by the distance between the x1 and x1 plus h. So in a way, you're getting the average speed or the average speed between these two distances x1 and x2. I'll talk about it with in more detail with a bigger example in the next video. But for now, you can just think about this. Think of how these values are changing, about functions, but you'll understand it properly in the next video. Okay, then that's it for today. I hope you have a great day ahead, and bye bye.